Hey, I'm here with Jim Turner. He's the founder of Optibike. He's been making electric bikes for like the past 18 years. It's 2014 now. And not only that, he's got a master's in mechanical engineering from Stanford. The guy knows his stuff. So I thought I would ask him about electric bike motors. So we're here at the Optibike headquarters. How's it going, Jim?
Good.
Awesome. So as you and I kind of know, it's like there's hub motors, there's mid-drive motors, there's belt drive things. Maybe you could just start off and give an overview of what's out there.
Yeah. And this is a kind of contentious subject of, mid-drives versus hub motors. And I liken it to probably front and rear wheel drive cars.
Mm-hmm.
People have been arguing about it for 40 years and they probably still won't.
Yeah.
About the benefits and attributes. And then you throw in four-wheel drive cars.
Oh,
maybe.
sure.
So, this is our views on it. But let's talk about what does it mean like a mid-drive. So a mid-drive, well, let's start with a hub motor. A hub motor is pretty self-explanatory. Is you have a motor that's in the wheel.
Mm.
So in this, you got a hub motor is in the rear wheel. And you can also have a hub motor in the front wheel.
And for those who might not know, a hub, that's just like the spindle that goes through the center of a wheel.
Yeah, that's
where the axles
the hub,
connect.
where your gears are and stuff, and the wheels, the rim spoke to it, so that hub is what's in there.
Got it.
And so you got a hub motor. And the other type of drives are called mid-drives. And the reason they're called mid-drives is because they're in the mid of the bike.
Yeah.
But the other important thing about the mid-drive is what they're doing is they are in between your pedals.
Mm-hmm.
So they're actually turning the sprockets kind of in parallel with your pedals. And what we're going to see is why that's an important distinction. So the hub motors tend to be on the rear wheel, and they just drive the rear wheel directly.
Okay.
Now the hub motor can be, you'll hear two types. There are direct drive, and there's also geared
Cool.
drive. Now this might get a little confusing, but what this has to do is inside this motor, they can either just, the magnets of the motor can directly drive the hub and the wheel, or they can have a smaller motor with gears and drive it.
Okay.
So there's two types. The advantage and disadvantage is when you have a direct drive, you tend to have a pretty big diameter there.
I've noticed
and be
that.
heavier.
Yeah.
Because the magnets have to generate enough torque, so you need a pretty big motor.
Okay.
The geared motors will be smaller, but then you have the gears in there, so there is some wear. And in theory, a direct drive could last forever.
Interesting. And one of the other sort of benefits, I guess, is I've seen that you can have sort of regenerative braking or regen modes with gearless motors, right? So on the one hand, they're heavier, but they're a little more durable. They're pretty quiet. And you could do regen braking. Do you have any, can you provide an indifferent point of view on like regen braking? Because people often say, gosh, it's so expensive, it's just not worth it because people don't weigh enough or something.
Regen, again, with electric bikes, the big thing we see is with a car, regen makes a lot of sense because a car weighs 5,000 pounds typically.
Yeah.
When you slow down, that's a lot of kinetic energy that can be transferred back into the battery.
I see.
When you have a bicycle, if you think about the way you ride, most of the time you coast, and you even going down hills, you tend to pedal. Unless they're very steep, you don't use the brakes much.
I see.
So, and then with a bicycle, you only have you and the bike, a few hundred pounds of kinetic energy.
Yeah.
So there's not as much energy to recover as there is with a car. And you think about going down a steep hill on a car, and you have the brakes on or have it down second gear, the whole time.
Yeah.
On the same hills I go down on a bike, I'm pedaling.
That's true. Yeah. And maybe the air resistance. I mean, on a bike, you're like upright,
And so there's less. People say it's maybe 2-3%, somewhere in there. So the drawback is there's a complexity of that because if you're going to have regenerative braking, that motor also has a little bit of resistance when you're pedaling.
Oh.
So if you want to just pedal it like a regular bike, you're going to actually be just even if it's not regenerating, you're going to feel a little drag because of those magnets in the wheel.
Interesting.
So you got some losses there. And so, there's some trade-offs there.
And financially speaking, you mentioned complexity. The system seems like it would need to be more complex. You've got more computer stuff going on, and it seems like they're more expensive.
Yeah, I don't know if they're really more expensive. There is more electronics because you have to put the energy back into the battery. And something people don't realize is the amount you can regen is limited because you have to push that energy back into the battery.
Oh.
And so when you put on the brakes really hard, and this is true in a car too, they can't regen. There's too much energy too quickly.
Okay,
So-
wait, one more question then. Okay, so this just came up on the forums actually. Someone was like, what if you get a regen bike and then your commute is way up a big hill and on the way home, let's say you charge it at work, it's full, you're full capacity, and you regen all the way home down that hill. Can you overcharge the battery by regen?
You shouldn't be able
Shouldn't
to.
be same thing, battery management
if
system.
It's built well. I know.
So you're like, it depends, okay.
Yeah.
But
if you,
probably not.
And those are the one example. If you have a hill, where you could regen all the way down. Those would be some examples where the regen could be better. But for most people riding, the up and down hills, you don't use the brakes much, so there's very little regen available.
Interesting.
So there is that complexity, and what we don't like is, if you want to pedal a bike freely, you have this drag sort of thing that's going on.
And to clarify again on that, so, for the most part, let's say you have just a standard direct drive gearless rear hub motor, and then you've got a standard geared rear hub motor. Do they both freewheel pretty much the same? I mean, it's not like the gears have to turn when you're coasting.
Right. Most of them the geared motors have a clutch, just like a bicycle does in the wheel. So when the wheel spins, you're not moving the motor at all.
Okay.
But if that's a regenerative, they can't have the clutch. They have to be driving that motor all the time.
Great.
And that's fine if you're regenning, but what about if you want to pedal like a normal bicycle? You got this like drag going on, which is a pretty significant portion of an average person's power they can put out. Okay. So then it can be a problem. So you got to kind of, there's a bunch of trade-offs.
Yeah. Well, having this knowledge, being armed with knowledge is the best way to go about. Thank you for being so articulate with all of this. So I think, what we just talked about, we were like direct drive or geared drive, hub motor. And the interesting thing is, it's like that could be your front hub motor or your rear hub motor. So we just killed two birds with one stone, it seems like.
Yeah, and then we got to talk about mid-drives.
Mid-drive is where we're headed next. Okay.
So the big difference, as we talked about earlier, is the mid-drive is up here with your pedals. And what it's doing is, you remember on your bicycles you have gears. Bikes have gears. So what do the gears do? If you think about your bike riding it by yourself, why do you have gears? Because you're selecting a gear for the particular hill that makes it easy for you to go up and down.
Yeah.
So you're always selecting the right gear. You remember the old-fashioned bikes were gearless and they didn't ride too well. So they developed bikes with gears. So that means a human can ride the Tour de France and go all these steep hills, right, and still go pretty fast down the flat, like do the Tour de France. So the mid-drive is using all those gears, so it has a wide range of ability to climb hills and go in the flat.
Got it.
But with the hub motor, and this is where I'm going to the contentious ground here, because the hub motor doesn't like this, but the hub motor is fixed. It's a fixed gear, just like a fixed gear bike. So when you're going up the hill, the hub motor has to introduce more current, what we talked about in our other video, into the motor to sustain the torque to go up there. Whereas with a mid-drive, you just downshift some gears and you can go up the hill.
So potentially more efficient, you make it last a little bit longer, the same battery power?
Exactly. The battery's going to last longer because mid-drives have the same efficiency all the time, whether you're going 30 miles an hour on the flat or 20 miles an hour or up a hill. So we rode the Optibikes up Pikes Peak.
Yeah.
They ran just as efficient as if they're on the flat.
And
whereas the hub motor isn't doing that because it's having to put more current in, so it's getting hot.
Yeah.
And we talked in the other video about batteries. It tends to have to take more current out, and sometimes you have to put a bigger a phosphate battery, which is less energy.
Very cool. And so to add in some of the pros and cons I've seen is a mid-drive does leverage your standard bicycle chain, right? And so you might be putting a little bit more force on that chain over time. The rear, sort of the hub motor design, doesn't necessarily leverage the gears that you're pedaling in. So if you were on a really steep hill, I've actually seen, and maybe you can comment on this, people have talked about, I'm a real heavy person, I'm going up a hill and the motor just stopped. Do they sort of have like an overheat sensor or something like that?
Yeah, most good motors today have a sensor, and what they're sensing is that extra current is heating up the motor and the efficiency is going down and it goes off as heat.
Okay.
And then they just stop.
So that it doesn't wreck itself, right?
Right.
Okay.
You don't go anymore, so.
Great. And is that the same with mid-drive motors, if they're also pretty smart?
Yeah, most of the bikes are getting better. A few years ago they weren't.
You're having to generalize here. I appreciate it.
Someone said that about our sim. They said, I hope battery would overheat, like I got to put temp sensors in it. Like, of course we have temp sensors in it.
Yeah.
You have to protect the battery, you got to protect the motor because they can't get too hot. So the modern bikes are getting really sophisticated. There's sensors everywhere. There's microprocessors running the bikes, doing all that. So you don't have to as a rider.
And you guys are kind of on the forefront in that sense, like with the SIM, the super integrated motorized bottom bracket thing that you've got. It's pretty cool because it's like got the battery, you've got the motor, and it's sensing torque and like there's a bunch of factors in there. And you mentioned a clutch. Can you talk about how that works so that?
Yeah, with the mid drive, we have a couple clutches. So we mentioned you didn't want the drag of that motor, so you can ride the bike completely without drag like a regular bicycle. And then the motor can also run without turning the pedals, so you can run just as a motor only. So you can kind of use it as a scooter. So it's very versatile in that respect. Okay.
And then back to the Pioneer All-Road right here. This one has the pedal sensing, sort of like cadence sensor. Can you talk about how that works?
Well, that's a sensor on the pedals inside the motor. So it senses when you're pedaling and then basically turns on the power instead of using the throttle.
Okay, sort of like an on-off switch.
Pedelec.
Okay, great.
A good thing I want to talk about, a little thing, Corey.
Yeah, let's do it.
Big thing in the news now is the Copenhagen wheel. And there's a lot of discussions about those wheels, and they'll heat up because the batteries are in there. And the Sim also has the batteries. It's sort of a Copenhagen wheel in the bottom bracket.
Oh, yeah.
It's an all-in-one unit. Not as simple to put on as a bike, but it is an all-in-one unit. And it brings us down to people say, well, those hubs, all-in-one hub motors potentially heat up the batteries and cause problems. And this is one of the problems here is we talked about, like people say, well, the Sim doesn't do that because this mid-drive doesn't get hot like a hub motor does going up the hill.
Interesting.
So there's less heat generators. So there's a lot of design going into this of what you can do, and it really highlights the difference here of what's happening when you try and do an integrated system.
Does it get less hot because it's not necessarily turning as hard because you're leveraging those gears?
Exactly. And I can do it like a typical bicycle has a 4-to-1 gear ratio. You get a little geeky here.
Sure, that's okay.
So if you go from your lowest to highest gear, you have 4-to-1 gear ratio. So let's imagine a hub motor bike and a mid-driver going up a hill, and they're fine on the flat. They're going along, whatever, 20 miles an hour, and they hit the hill.
Yeah.
So the guy with the mid-drive starts downshifting, and say he gets really steep. So he eventually goes to first gear, which is a 4-to-1. So he has 4 times the torque going out his rear wheel to go up that hill.
I see.
The hub motor, though, as we said, is fixed. So it says, wow, I need 4 times the torque. Where do I get 4 times the torque? Well, I go get 4 times the current from my controller and my battery. So I bring in 4 times the current. The problem is the losses are the square of the current. So you bring in 4 times the current, but you get 16 times the heat generation losses. And you get 16 times the losses coming out of the battery. So not only is the motor heating up, but the battery's heating up and draining quickly. So
I see.
the efficiency starts to go down. That's why you run into that problem with suddenly they're overheating on the hills. They can't dissipate the heat fast enough.
Well, it's wonderful to hear that. And you guys focus on sort of these off-road ready bikes that can climb. And again, you're leveraging that rear cassette, you're leveraging the gears just like a person would. You don't want to hurt your knees, you don't want to overheat yourself, you change gears. And I want to call out, you're right, not only is there like the Fly Climb, the Copenhagen wheel, and the Electron wheel, but another benefit that I've noticed about like mid-drive is that the rest of the bike kind of remains unchanged. You can take it to a shop and they can service the cassettes, they can do all that. And it's, if you're out there riding and you break down and you need to change the flat, like good luck if you've got a hub motor and it's like bolted on and then you've got to tighten it again to the same strength. I mean, it's just a reality of hub motors. Now, again, I enjoy hub motors. Sometimes you're cruising around on the flats and it seems fast and zippy. But it's like what you've said before about finding the right bike for you or for the right application.
Right.
So.
And I do have a story.
Do it.
Story about when I started long ago when I wanted to build an electric bike.
Yep.
And I had the greatest ideas. What I needed to build was a direct drive hub motor. Because from an engineering standpoint, I said it was super efficient, direct drive, no gears, no losses. It's going to be great. So I hired a really good motor designer guy. And I said, build me this hub motor. This is the torque and stuff I need, and all that. And so about a month later, he came back with a computer analysis, and he says, here it is, it's not that good, and I said, yeah, it's not that good, and so I go try again, and about a month later he called me, he says, that's a dumb idea.
Huh.
I said, what do you mean it's a dumb idea? He goes, it's going to be really big and bulky and use a lot of magnets and be heavy.
Yeah.
He goes, it's not a good idea. I don't want to work on it anymore.
Oh.
So I was really bummed out because I was going to build this great electric bike, with
Yeah.
the motor so efficient. And
It's like right when you were starting. Yeah.
yeah, right when I was starting, and I was bummed out. I go, well, there's nothing here for me to do. And so that went on for like a month or two. I was just bummed out, and I was out riding my road bike one day, and I was riding up a hill, and I got thinking, I go, wow, the bicycle has evolved over 100 years to be this super efficient piece of machinery, right?
Yeah.
It's the most efficient form of transportation there is.
But yeah, right? That's Steve Jobs. It's a computer for the mind.
Yeah,
Or for the
it's the
mind.
most efficient form, and they've done all this work making the gears and all that stuff, and I go, why don't I just slide the motor in parallel in the bottom bracket? Because I'm keeping all that bicycle efficiency,
Yeah.
and I'm just adding it in. And then I got thinking, because of my study at Stanford, is I go, wow, the battery and the motor are actually very much like your leg, too. They like to run at one kind of speed,
Yep.
just like your leg does, right?
Yeah.
And you can put out a huge amount of torque when you sprint, and what happens to your leg? It starts to burn.
Yeah.
Same thing happens to the battery. We talked about it gets hot.
yeah.
The motor gets hot. It
Higher
doesn't like
speeds.
that. It can do it, but people talk about motors having infinite torque. Well, in theory they do, but just like your leg, it burns out.
Yeah.
And that's how the mid-drive really came about for me, is I realized they were similar systems, and since the bike was optimized for my leg, and the motor and battery were similar to my leg, they would work in harmony together.
I like it, and there's these other happy sort of coincidence that it's in the middle of the bike, keeps it balanced, so you're not necessarily, your weight's kept lower in general, and it's not going to like fishtail, or if you're going to mount it on a rack or something. That's something I always think about because, I don't ride from my house all the time. I take my bike places, and, I want to be able to lift that bike effectively, whether it's carrying it upstairs or whatnot. So this has been wonderful. Do you have any other thoughts on electric bike motors to share with us today?
That's about the basics of it. I think you just touched on the weight distribution is really important. Weight on wheels is very a no-no.
Oh, okay, and that's as far as suspension. Like if you imagine a full suspension electric bike where the hub motor is in there, now you're like adding weight.
It's called unsprung weight.
Okay.
And when I worked at Ford, I was an advanced vehicle controls engineer.
Cool.
And they came out with a project. This is how important weight is on wheels. They said, we will fund every project $1 million if you can take 1 pound off the wheel of a car.
Oh my gosh, is that top secret? Are we allowed to share?
That was years ago.
Years ago.
But it just
Declassified.
shows the importance of weight on wheels, that Ford was willing to do that with a car wheel is already 300 or 400 pounds.
Wow.
And we were working on carbon fiber shock absorbers to reduce the weight of the wheel.
Huh.
It was so critical because that affects the whole dynamic of the car.
Interesting.
And I liken it to a simple thing, the kettlebells for training.
Yeah, yeah.
So if I throw you a volleyball,
Yep.
or I throw you a kettleball,
Yeah.
which do you want to catch?
Oh, I want the volleyball, of course.
And the same with your wheel. When it hits and it's flying up at you,
Mm-hmm.
if it's a kettleball, the suspension and you have to absorb that energy, where if it's a volleyball, it just kind of floats into you. It's really
Interesting.
easy to do.
Does this play a role with spokes and bending and breaking spokes at all, or is it because it's a hub motor that doesn't?
There is more, because there's more energy in the wheel. When you accelerate a wheel that weighs 20 pounds versus 5, you have more energy that has to be slowed down. So potentially it can wear out faster.
Inertia.
But the real thing is the dynamics. You look at all racing vehicles, they do everything to reduce the unsprung weight. Everything. So a lot of people say hub motor is great. You're riding around town, you're not going very fast, and I would agree with that.
Yeah.
You put one in the rear wheel, and if you're just cruising around town, and there's not a lot of hills, there isn't that much difference. But if you're building a performance vehicle, especially what our Optibikes are, where you're going on trails and doing that wheel is can be very dangerous. I don't like to say it because I don't want to slam hub motors, but
Sure.
it's just the physics of it. And,
Yeah.
and like, again, I posted this on the forum the other day, is the electric bike industry should come out with categories of electric bikes for the consumer. Maybe 5 categories so we understand kind of what we're buying, a in-city, kind of low-speed electric bike versus an all-out downhill type mountain bike.
Sure.
And so they're not disappointed with what they're getting.
Yeah. Well, this helps a lot, that, again, this is like education series, and I know you own a company and you've got a product, and it's a great product. And but I really appreciate you giving kind of as much as we can, sort of that unbiased perspective about how these technologies work. I know you think about it all the time, and Jim, it's been a real pleasure hanging out.
And we're obviously biased, but I do say, like I mentioned with the hub motor, we started there. We started with other batteries. We've been there, and so what we have evolved to where we are, and a lot of other companies are evolving behind us. But it's out of experience. It isn't out of some ideology. We're anti-hub motor. We just realized its limitations. And
well, and you're out there. I mean, look out the window. There's those mountains right there, and you guys are out there riding on them, right? So, giving it a go. Thanks again, Jim.
Okay, great.